All right. Hi, folks. I'm Anant, and this is State of CI in the SciML ecosystem. So with this talk, I kind of want to give folks a broad overview of the processes we use in the SciML ecosystem for CI/CD. This is basically non-negotiable at this point, especially with the size that SciML has grown to. And so the first question is what runs where, and where all these run. So most of our CI jobs are run on Linux. There are some packages that run on Mac OS and Windows as well. We primarily use two CI providers, GitHub Actions and Buildkite, and most of these are for different kinds of workflows. So to start off with, let's talk about GitHub Actions, and I think that's probably more relevant for folks in general. So GitHub Actions is used for more general purpose workflows. This is running tests, package tests, format checking, and so on. And these are all typically run on GitHub's hosted runners, so we don't have our own dedicated machines for these, or we don't have dedicated queues for these. They're kind of, they're typically considered to be essential in any SciML repository at this point. If you import it, if you're importing a new repository into the organization or creating a new one. So this is what you're likely to see more across SciML repos. So how do you get started? The answer is two words. It's using our centralized workflows. And centralized workflows is this new thing that we've been rolling out over the course of the past year. And how does this work? It's super simple. We basically have all our workflows defined in a central location in SciML/.GitHub repository. And all you need is just this one liner in your job definition, and then it'll automatically run for you. So why exactly did we come up with this? Besides convenience, there were also like active pain points that motivated this. Previously, the CI workflows that we had were basically just copy-pasted from existing repositories without any particular pattern or reason. They were not maintained. They were only tweaked when something broke down or like some very specific niche case came up. And when that gets copied over to a new repository, that tracks as well. There's also the other issue with these kind of copy-pasta workflows, wherein it's not always intentful, so it ends up being more wasteful. So even if you don't need to run Windows CI on your specific repositories, you end up running it anyway, and that just eats up CI time and usage minutes. More importantly, it's very difficult to propagate changes across the ecosystem whenever there are disruptions in the dependency change distribution. The biggest example of this is CodeCurve. When CodeCurve broke, all of SciML went, red like within the span of 1 day, and then we had to put up like over 100 PRs just to fix that, and that's not feasible. I mean, even if you can do it, it's not a pretty task to do. And this was before we had Claude to do these kind of things, right? So what all of this culminates in is a whole bunch of unmaintained and outdated workflows that are kind of inconsistent and painful to update, which is why the solution is centralized workflows, obviously. So why does this work? It's because it's a single source of truth, and we've set it up with sensible defaults, which is a very important thing here. So when we are migrating over to the centralized workflows, we took care to make sure that the status quo is maintained, that each and every repository's workflow needs are all taken into account, and we derive all these kind of patterns and commonalities between these workflows while moving them over. They are extensively configurable as well. So if you want to configure any of these default values, like if you want to turn off your coverage, or if you want to run your Julia tests with a different dep1 flag, right? You could just as well do that. And they have a staged rollout process right now. So how this effectively works is anytime there's a new change that's proposed or new change that we want to introduce, they're first tested in individual branches on isolated repositories. Once they're verified to be working there, they're kind of promoted to master, which might seem counterintuitive, but it's not really so much. There are select repositories like Modeling Toolkit, which are kind of beta testers for this master one. And these are all high volume repositories that see a lot of activity. So if someone breaks, I know someone's going to yell for sure. So once they're verified to be working there as well, and there's no issues, then it's promoted to a release branch of sorts. The release branches kind of ensure that if these workflows ever have a breaking change, like for instance, if you move away from Julia formatter to using Runic or something, then the onus is not on the package maintainers to update all of their packages at the same time, right? So you can have a measured release process for these things as well. Finally, they're also generally available as examples for other organizations. This allows people to contribute their thoughts on these kind of things as well. For instance, I know that there's a Quantum Kit Hub organization that has adopted these workflows as well. And so what kind of tests do we run with this? We run tests, we run documentations and format checks with suggestions on PRs right now. We have downstream tests in the works. We have downgrade CI that actually works with Stefan's new implementation of the SAT solver coming up. We have minor benchmarking jobs that aren't intensive enough to be in SciML benchmarks there as well. And then we're also planning on looking at dependency management for the reusable actions within the workflows as well. Next one is build kite. I'm going to speed through this real quick because I have a few slides and I think I have like 3 minutes left. So the build kite setup is hosted under the JuliaLang build kite account. So we have access to like 116 agents, and a lot of them are AMD CI. But we don't use all of these because we don't have to, because I don't think we run a single SciML workflow on FreeBSD, for example. So what kind of jobs do we run on build kite, right? So these are typically jobs that are very heavy workloads that are either resource intensive or time intensive, or require GPUs, or they're a combination of all of these. We also use a lot of custom build kite plugins, for instance, for memoizing the repository, so we save on inefficient builds, and for security, for sandboxing, and all these things. Currently, we have 32 SciML repositories that run on build kite, but some packages use build kite a little more than the others, which we'll see in the usage section of this. So how do you get your repository to set up to run jobs on build kite? It's really simple. You just set up a new pipeline on the build kite's web UI. Then you set up a GitHub webhook to hook it into your repository. And once that's set up, you just need a simple pipeline file in your repository. So if you think your packages have workflows that are intensive enough to warrant running on build kite, please get in touch and we can work it out. Right. So now we come to the usage stats. This is a relatively new GitHub feature, which I'm glad came out right in time for my JuliaCon talk as well. So this information here is only from February 2025. So it's the last 6 months, right? So across SciML, we've seen usage of little over 3.5 million minutes of CI time for Linux machines, and 88,000 minutes of macOS machines. The action storage is basically what we use for caching. Ordinary DiffyQ is absolutely on top of the leaderboard with little under 900,000 minutes, with MTK closely behind with almost 800,000 minutes. MTK has had over 100 releases this last year, which probably explains this as well. Next, we also have the build kite usage stats. So build kite has had this for a while now. So this is since last JuliaCon, that's 13th July 2024. There is one package that almost hit 500,000 minutes of CI time, and I'm pretty sure it'll cross that mark over the next couple of days. I don't think there's going to be any prizes for guessing that this is ordinary DiffyQ. Of course it is, right? So I'd also like to point out SciML docs here. That's a bit of a special case because these are jobs that generate, aggregate documentation with the help of multi-documenter and finally deploy to docs.sciml. Given how quickly things move in the SciML ecosystem, we want these to be up to date. So this is set up to run every couple of hours. But yeah, that's about it. And that brings me to close. If there's any questions, we can talk.
Yes, we have time for about one question. How many person hours did it take to develop this pipeline?
Oh, man. So this was before Claude, so I would say a fair amount. Yeah.
Yeah, with the CI stuff and build kite, we've had some success integrating with the results test suites within build kite. I don't know if you're familiar with it, but it's quite good because it can track kind of flaky tests.
Yeah, so we do see that, but typically the SciML ecosystem just moves so quickly that most results just automatically get resolved by the next release itself. Most failures. So which is why I didn't put up the statistics for the flaky tests on there.
Okay, great.
All right, we should cut off questioning right there. So let's thank the speaker again.
Thank you.